Nice little straightforward question. It's a prove question, profiwch. So you've either got to start on one side and reach the other. So it doesn't really matter. In this case, it makes sense to start on the left-hand side. So we've got sine cubed plus sine theta cos squared theta, all divided by cos theta. So we need to start on one side and go from there and deal with it. So I'm going to start on the left-hand side in this particular case. So I'm being a little bit lazy. I'm going to write s cubed plus sc squared all over c. And I've now got to ask myself the question, what can I do with that? And the obvious thing I can do is to draw out a common factor from the top. And remember that taking out a common factor is just the same as dividing each term by it. So sine cubed divided by sine is going to be sine squared. I take 1 off the power. And I'm clearly going to remove 1 sine from that second term there. And then ending up there. So I've got s over c. And then I've got a s squared plus c squared. And remember that I was being lazy, saving my writing skills. Not that I've got that many of them. So I'm just going to choose to rewrite this as this. Now, being evil, deep, mean, and devious, I know that I've almost got my answer. But in order to do that, I've got to show why that is the case. And if I've got any old right angle triangle, because we know that sine, cos, and tan, we learnt these years ago in probably year 9, year 10 trigonometry, depending on where I am, and they're using thetas, so I'm going to use thetas. And we know that the three sides are the opposite, the adjacent, and the hypotenuse. Interestingly, hypotenuse actually means length under, but I don't quite know why that's the case. But I'm going to choose to call these the sides A, B, and C, sticking to a right-handed version of the world. I started at the top and worked round clockwise. And I know certain things in this particular case. I know that I'm going to cheat and make this a nice easy little triangle and make this side 1. So I'm going to choose my side 1, or side A, to be of length 1. Now I know that the sine of that angle is going to be its opposite side divided by its hypotenuse. That's why I made it 1, because it makes my life easier. So therefore it follows that B is equal to sine theta. And also, if I use this C side, which is my adjacent, posh word for next to, because it's next to the angle, it's not the hypotenuse, then what I'll get is that my cos of my angle, theta, is equal to my adjacent side over my hypotenuse. So I've now got that these two signs here, I'm going to change sign, like a little bit of red coming in here. So this side here is sine theta, this side here is cos theta. You see what I did there? C equals cos theta. And by my trusty Pythagoras, we know that if we square both sides that are not the hypotenuse and add them together, we'll get the square on the hypotenuse. So fairly obviously what I've got is that sine squared theta, and that's the notation that we're using for the sine of theta all squared. And we don't put the squared at the end where we would normally put it, because people would be thinking, is that theta squared and then sine it, or vice versa? So the notation is that we will use is that. You notice I've used exactly the same, is congruent to notation, it appears in the questions as well. So what I've got here is my sine squared theta plus cos squared theta has got to be equal to 1 squared. Oops, helps to put your theta in. Equals 1. So sine squared plus cos squared equals 1. So what I can do now is go, hang on, I've got s over c times 1, and 1 being the multiplicative identity means that that's just s over c. I'm going to shift on to my page now, and so what I've got from my left hand side comes back as just being s over c. But I'm required to prove that that's tan theta, and it is, I know it is, but I've got to think about why that's the case. Wouldn't have to do that under exam conditions, but if I want to understand why I'm doing it, then I need to keep the situation. So I'm going back to my right angle triangle again. I've got my angle theta here, and I'm going to stick with the lettering I had before, A, B, and C. I'm going to avoid the 1 in this particular case. So we know from our early trigonometry work at GCSE that the sine of theta is the opposite over the hypotenuse, so it's B over A. The cos of theta is the adjacent over the hypotenuse, so that's C over A. And we know that the tan of theta, because we were told this was the case, is always the opposite over the adjacent, so it's B over C. Now, if I take what I've got so far and I put the sine of theta over the cos of theta, what I've got is B over A, all divided by C over A. And generally, if we're dividing fractions, what most people do is they reciprocate or turn the bottom one upside down, so that becomes A over C, and they change it to multiplication because it's much easier to deal with it. Okay, oh look, A's cancels, leaves me B over C, which is therefore tan of theta. So I can claim, and I'm actually going to do it so that just to show that I can actually do the writing, sine of theta over the cos of theta, which is equal to tan theta. And when I was in school, we used to have to write quod erat demonstrandum, which I have now shown. But seeing as, and that became abbreviated to QED, and nowadays we just draw a little square and shade it in. I have done it. And if I want to be ever so precise, is congruent to, is exactly the same. So I can now claim that my original function, which was sine cubed theta plus sine theta cos squared theta, all divided by cos theta, is congruent to tan theta. Aren't I clever?